So I'm running the recreation here, and I've got the main menu, and I've got some status symbols for Wi-Fi here. I've got an S at the top, and that's indicating that it's set up, the Wi-Fi module. P means that a page has come in the past, and C means it's been completed, and the W is just toggling on a certain number of idle loops of the core that is running the Wi-Fi. So there's two cores in the RP2040. The emulator is running on core 0, and the display update and the Wi-Fi, and there's also a real-time clock task manager, is running on core 1. And the way it's arranged, I have to have everything that's doing I2C on core 1, which is the real-time clock and the display. Otherwise you end up with two cores driving the same I2C bus, and because this is bit bashed, it goes horribly wrong. But anyway, that's the status symbols for the Wi-Fi here, and this is currently generating a Wi-Fi hotspot. I've had to upgrade the code on the Wi-Fi module because I wanted to use Bluetooth, and that means that the responses coming back from the module had changed slightly, so I've had to update the code, but fortunately it's all table driven, so I just add a few more entries in tables, and that just works. So fortunately as well, the AT command set I'm using for Bluetooth and Wi-Fi is very similar, so all I need to do to get Bluetooth working is put some more entries in my tables, and off it goes. But anyway, at the moment this is generating a Wi-Fi hotspot, and over here I've got on my laptop, I've got the output from just the index page. So at the top here, that's the IP address of the organiser. So if I just refresh the screen there we go. So ticks is updated here. That's just number of idle loops this thing's run. These are the memories inside the calculator, and down here you've got what's on the display. So if I move to the calculator with a C and then refresh the screen, you can see that the display's changed. And if I what should we do, let's put pi, oh hang on, let's put pi into memory 4. So then if I refresh on the browser, there you go, pi in memory 4, pi on the screen, pi in memory 4. I've got some other things I can do here. I can do, if I do memory, and then we go to say whatever address I want, let's go to 2000. That is now displaying memory, which is RAM at the moment. It's going straight into the RAM data buffer, and that's the value of the memory at that address. I can also write into the memory. I've got to write. Let's have a look at, if we go to address 8000. That's one of the banks of memory in this machine. What I can do then is I can go in and write 8000, and we'll put 34 in there in hex. And if we go back and refresh 8000, you can see that 34 is in the memory. So the reason that I wanted this is that I can now get in there, change values, look at values in the inside of the emulator, and do a bit of debugging that way, rather than having to run Eclipse and go in and do it. I can go in and now do things like update port values, so I can write to port 2 and put a value in there such that the organiser code will just see that port change. It saves me having to write code in the emulator to do various test things. So as well as memory, the two serial EPROMs, which are on the PSU board, so there's two of them, so we'll start with EPROM 0. and then we'll put an address there, so we'll just look from the beginning. So that's now read from EEPROM 0, and you can see there's Fs in there. If I read from EEPROM 1, which is the other device, well, there's Fs in there as well. Let's have a look at another address, see if we can find some data. So there's some data on EEPROM 1 at address 1000, and if I read EEPROM 0, address 1000, there's 5 5s. So what I've done, device 0 has currently got what I believe is a RAM dump. I'm still working on that code. If we go up to 4000, there's Fs there. Let's see if we can find some data. Oop. There you go. So EEPROM 0 2200's got United. I'm not sure what that is, but anyway, it's got data in there, and that's been copied from RAM. So not sure what that is at all. But if you go and have a look on device 1 at that address, there's FF. So it's never been written. That's the blank value. So they seem to be working. There's two 64k byte devices. So there's 128k bytes of serial flash, and at the moment it actually, if we come out to the main menu and turn off, it actually is now dumping RAM to one of those devices. It's also corrupting the display, and that is because the emulator is going straight out to the I2C bus and corrupting the display. But the time taken to turn off there is the time needed to dump, I think it's 64k of RAM at the moment, to the serial EEPROM. So it's pretty fast, and when it turns on there's now a delay. It stays blank and then it appears and starts up, and that is the delay needed to load it back into RAM from the EEPROM. It's quicker to load it in because you don't have the write delay. Now that's pretty fast, and that could be sped up, especially the read, by doing direct port accesses to the GPIOs for doing the bit banging, rather than going through the whole library code and my code as well. So it could be sped up a little bit. So yeah, that's Wi-Fi, and it's quite handy to be able to get in there and fiddle with things and look at stuff. If I bring the code up, there we go. So these are the URIs that I've got available at the moment, and basically it just does a pattern match on that and then calls that function to do whatever this URI needs to do. If I go further up, this is the table I've got that interacts with the wireless module, and whenever one of these strings matches, then there's a couple of functions and it goes off and calls the appropriate function. So the whole thing is table driven, and it's pretty easy to change what's going on. The actual actions that you perform at certain times are done in this table here. So here's Bluetooth initialization. So there's a label there which labels the beginning of the tasks, and you go in and issue these commands with delays between them, and the delays are not blocking, so the core that is doing both the wireless and the display update can do something while it's delaying. It doesn't sit there for 2 seconds holding up the core. This is to initialize the Wi-Fi, and then we've got other things to send data, and I think there's another one somewhere to send Bluetooth data. But anyway, actually it's the same task. It's so similar that you can use the same task to send the data, and that's how I interact with the Wi-Fi module. So it's pretty easy to add different messages. So for instance, this block of plus STA connected, STA disconnected, and dist star IP, they all appeared when I put new code on, and what I ended up doing was just putting those entries in the table and then ignoring them, so that was fine. While I was investigating those, I found out that there's 3 more messages that may appear, I suspect that's when the module connects to a Wi-Fi hotspot. At the moment it's generating a hotspot, so I put them in the table anyway, so in the future that will probably be okay. It'll just ignore those. But yeah, Wi-Fi is working. I'll change the code, recompile it, and do the Bluetooth version of this, because that's different. I don't have the same interface to that. In a lot of ways it's a better interface, so I'll do that. That'll probably be another video.